G'day gurus. Today I'm writing a bench testing script from scratch and explaining each step as I go. By the end, you'll have a working script and an understanding of how it works. Let's get scripting. The script will be designed to stress test the macOS CPU while collecting metrics: CPU temperature, fan speed, and frequency. I'm writing the script in a tune. Firstly, we need a function to collect performance metrics. This is where the power metrics package comes in. Let's write it together. Alright, so the function is going to be collect metrics. So we'll initialize a local variable and we will run the power metrics to collect and return only the lines that we want to see. It brings back a whole lot of data. You should run it to see all the information as a test. We want the CPU, power, and SMC. Now we want to grep on CPU die temperature, fan, and system average frequency. Now there's going to be a whole bunch of text in with those figures. I want to collect the figures specifically. So let's write the regex patterns. Now a trick with this is you can quite easily grab the line, throw it into AI program, and ask them to figure out the regex. And it does a fantastic job. A lot faster than I could have worked it out. But if you're smart enough, have a go. This will all be published, so you don't necessarily have to try and work it out here. You can just go and copy it off GitHub after this. I should have it in the description of the video if I was doing my job properly. That should be close enough. If I get it wrong, that's alright. We'll figure it out when we go to run this later on. So now, from the metrics variable where we've captured the information, we want to extract the individual figures. And then we want this function to return those values, just in a string form. Okay, so this function grabs all the metrics we're interested in and returns them as a space-separated string. We'll use this throughout the script. Now we need a function to stress test the CPU. We'll use BC to perform mathematical calculations, which will keep the CPU busy. We want a computation for each CPU core. We will have to grab the number of CPU cores later on. That'll be the variable for it. So the power metrics command takes roughly 5 seconds to perform. So the intensity of the test on the CPUs needs to take longer than the power metrics to return those values. Otherwise, the machine's going to sit in idle between tests. So the scale sets the position of the decimal point, and the 4 multiplied by A is, with 1 in brackets, is the mathematical expression that calculates pi using the arctangent function. And now that's being run as a background task, so we will have this function wait till all the background tasks are finished before it completes. And we have our stress test. So this loop runs 1 task per CPU core, calculating pi to 10,000 decimal places. The wait command ensures all tasks finish before moving on. With those functions ready, let's write the main part of the script. We'll collect initial metrics, run the stress test, and log performance data at each step. So I want to store these pretest metrics as a variable. We'll bring them back later in the log as well. I'm not using the function because I want it to print differently in the log. Now we want to know how many CPU cores exist in the system we're testing. So this command here will return the number of CPU cores, and we'll print this to the log. Now we're going to start our CPU performance test. So let's record the start time. We'll run the function to perform to kick off the stress test. It will run in the background. And while that's working, we'll collect the metrics and we can wait for that stress test to complete. Now we have to extract those metrics and store them in their own array. So what this is doing is that string that was returned, I'm just going to frequency percentage is the first item in the string, and we'll collect the rest just like that. I did have an issue where it was returning a new line, so we'll clear that out of the make sure that doesn't get returned into our, and we can print all these to the log now. Echo. But we also want to store these metrics. So that there runs a single stress test. I'll just run one compute through all the CPU cores and that's it. I would like to configure this so that we can, when we go to run our job, we can say we want to run it for 10 cycles. So after it starts the test, we click the start time. So just before running the CPU stress test, we want to add the create the loop. So this task count, we'll get that up at the top here. CPU task count. So I'm writing in a tune. So in a tune, we can pass in parameters. This parameter already exists in my project. So we see it here. This loop stresses the CPU, collects the metrics, and stores the results. Each cycle gives us a snapshot of the system performance. Finally, let's summarize the results. We'll collect maximum, minimum, and average values for the metrics. So to find max and min, I do a sort and return the first value in the sorted results. Okay, so that returns the max and min values that I'm interested in. I want the average temperature. So now we've got all the values that I want to summarize with. So we've got the temperature, we calculate summate all the temperatures and then divide it by the number that was collected. So to output the results, try to make it look nice. Now we'll print again the pretest metrics so we don't have to scroll up the log to find them. And to capture how long the test took as another metric. So we already captured the start time. So if we record the end time at this point and calculate the time elapsed, I want it to be readable. And that's it. The script is complete. We've written it step by step and now it's ready to use. Let's execute the script. I'm going to configure the job to run 10 loops of the CPU intensive task. So here's my plan in a tune. So when it runs the job, it'll plug that parameter, the CPU task count parameter with 10. And the job is sitting here. So here is the code. I can edit this within the job window here. But if we look at that CPU task count, this is the actual script that will run. It has plugged in that variable that I configured in the plan. Now, let's see how many typos I put in there. If we run that. All right. There we go. Look at that. Hey, why didn't you tell me about that one? Line 38. So let's go back to our code. Oh dear. Dreadful. So fix those couple of mistakes there. Save that. Let's have another go. Thanks for scripting along with me. This script is a great example of how you can use Bash to create practical tools. I'll share the full script in the description below. Please share your thoughts in the comments. I'll see you next time.